this session. In this session, we are going to see about the two more scheduling algorithms called the priority scheduling algorithm and round robin scheduling algorithms. Now, let us see about the priority scheduling. So, in this scheduling, a priority is associated with each job and the CPU is allocated with the process which has the highest priority. If any two process has the same priority level means then FCFS scheduling algorithm will be followed for that two process. Now let us see one example, and here the priority numbers will be assigned from 1 to 7 here. So the process burst in and the priority level. So here there are 5 processes P1, P2, P3, P4, P5. So P1 order priority 3, P2 order priority 1. Again P3 order priority 4, P4 order priority 5, P5 order priority 2. So the priority which has the number 1 has the highest priority and other priority level will decrease item. And let us see the Gantt chart. So the highest priority means first one priority P2 process. So P2 will be executed first, and next the P5 has the next priority, second priority. So P5 is executed, and next P1 has the third priority. So P1 is executed, and P3 has the next priority. So again P4 will be executed. And finally P4 has the last priority, so P4 is executed. So now let us see the average waiting time for this priority scheduling algorithm. So P1 வந்து P2 and P5 complete பண்றதுக்காக wait பண்ணனும். So அதோட waiting time 6, and P2 it has not to be wait for any other process, so அதோட waiting time 0, and P3 has to wait for until P2 and P5 and P1 is completed, so அதோட waiting time 16, and again P4, so இது வந்து first 4 process P2, P5, P1, P3 wait பண்ற முடிக்கிற வரைக்கும் wait பண்ணனும், so அதோட waiting time 18, and let us see for P5, so அது வந்து P2 முடிக்கிற வரைக்கும் wait பண்ணனும், so அதோட waiting time 1. So மொத்தம் 5 process, so 41 divided by 5, the average waiting time is 8.2 millisecond. And the priorities, it can be either internally assigned or externally assigned. And the internally defined priorities use some measurable quantities for the setup process. And the externally defined priorities, so that are set by some criteria by the OS. And this priority scheduling, it can be also either preemptive scheduling or non-preemptive scheduling. Now let us see one of the disadvantage. So that the disadvantage of this priority scheduling algorithm is the starvation problem, that is indefinite blocking. So some of the process which has the lowest priority, it must be wait indefinitely for the until the completion of the higher priority jobs. So indefinite or lower priority jobs வந்து in highest priority job முடிக்கிற வரைக்கும் வெயிட் பண்ணிட்டே இருக்கணும். So that is one of the disadvantage of this priority scheduling. So அதை overcome பண்றதுக்காக let us solve this problem by using aging அப்படிங்கிற கான்செப்ட் யூஸ் பண்ணி நம்ம வந்து சால்வ் பண்ணலாம். So the technique of aging is gradually increase the priority of some jobs that is wait indefinitely in the queue. So அதோட low priority job ஓட அந்த priority level கொஞ்சம் கொஞ்சமா gradually increase பண்ணோம் அப்படினா that will be executed, that process will be executed by the CPU immediately. So that is the disadvantage, and the problem solved by aging technique use பண்ணி solve பண்ணிக்கலாம். And next one is round robin scheduling. Here this round robin scheduling algorithm, it is mainly used in time sharing system. Here a small unit of time called time quantum or time slice is defined, and this time slice, it can be either 2 to 100 millisecond, and the over process may that time quantum mattumna execute pannom. So after that there will be a time interrupt vandrum, and the process immediately stop ayirum. Next process the same time quantum time மட்டும் execute ஆகும். Again that will be interrupted and this process will be continued until the execution of all process has been completed. So here, the round robin scheduling algorithm is completely a preemptive scheduling algorithm. ஏன்னா நம்ம நடுவுல வந்து ஒரு process-ஐ வந்து terminate பண்ணிட்டு அடுத்த process-ஐ execute பண்ண போறோம். And here also one example, first process P1 burst time 24, P2 3 and P3 the 3 millisecond the burst time is. So இதோட Gantt chart, let us see the Gantt chart. So P1 வந்து இதோட time slice வந்து 4 millisecond. So let us consider like this 4 ms. So ஒவ்வொரு process-உமே 4 millisecond மட்டும் தான் execute ஆகும். So first process P1 4 millisecond execute ஆக முடிச்ச உடனே there will be an interrupt, அதை preempt பண்ணிட்டு அடுத்த process P2 அது 3 millisecond execute ஆகும். Next P3 அது ஒரு 3 millisecond execute ஆகும். முடிச்சிட்டு again P1 வந்து இன்னும் remaining இருக்கு. So 4 millisecond execute ஆகி 30 வரைக்கும் நமக்கு வந்து execute ஆகி முடிக்கும். So here the average waiting time equal to first process வந்து first time 4 execute ஆகி முடிஞ்சிருச்சு. So அதனால 10 minus 4 போடுறோம். So 6. அடுத்தது P2 process, it has to wait for 4 millisecond. So அதோட waiting time 4 and P3 has to wait until 7 millisecond. So 6 plus 4 plus 7 divided by 3 equal to 17 by 3, that is equal to 5.66 millisecond நமக்கு execute பண்ணா போதும். And here is the one problem is context switch. So at the end of each time quantum, so we will get some interrupt from timer la or interrupt varum, and here we have to save all the registers for the old process and load the registers for the new process. So this process is called context switch, and the smaller time quantum நம்ம கொடுத்திருந்தோம் அப்படினா it will increase the context switch also. So that is one of the disadvantage of this round robin scheduling algorithm. So that's all about this concept. Thank you.